Node app, completely with streams, using a total streams architecture from beginning to end, where everything in the app is a stream and it's all about streaming data. And I kind of flippantly answered that. It doesn't seem like you could do that. But then I was on a trip to the States and I was browsing around one of the electronics shops and they were selling one of these things. Does anybody have one of these? It's called a Sphero, and it's this kind of little, dinky little robot that you can drive around with your phone. You can directly go left and right and roll forward and go at different speeds, and there's all little games that come along with it. So I bought it for the laugh and decided I would just start playing around with it. But of course, curiosity got the better of me, and I went on Github and looked to see was there a Node driver for it. Of course there was, so I had to try it out. And of course it didn't work properly, so I had to debug it a little bit and that sort of stuff. And then the idea came along, well, you know, this is all about streaming data. The key commands that drive the robot, and then the robot's idea of its location and that sort of stuff. So is this a way to create a Node app that is entirely driven by streams? Do you guys, a lot of you guys are doing Node now, I guess. How many of you guys are doing it day to day? Or is your paycheck dependent on Node, I guess is the right question. One of the things that we've seen in nearForm, people sometimes have a difficulty with getting used to is how streams work in Node. And it's a particular way of thinking and getting your head around how they work. So what I want to do with this talk is build an app that uses streams to drive the robot and takes instruction from the robot, but build it up step by step, piece by piece, so you can see how each individual stream fits together and how you use different types of streams and hook them together to eventually get to the point where you want to be. The idea is to kind of cover a lot of the different concepts around how streams work in Node. So if you want one yourself, right, they're about $120 US. You can pick them up in airports very easily, or you can buy them at GoSphero.com. They're a bunch of fun, especially if you have a cat. He zooms around the place, the cats love to chase them. So hopefully the end result of this talk will be put the thing on the floor and it will buzz around and I can drive it from the cursor pad on the machine, if Bluetooth plays nice sometimes. It doesn't, so we'll have to see. Just in terms of how it works and why this is possible, the particular company that makes these robots open sourced their protocol. So you can actually download a PDF that tells you how it works. And it's a binary protocol over Bluetooth, so you're essentially just exchanging bytes with the robot. And because they've defined it in a really nice way, it's possible to write a driver in Node, and there's actually 3 or 4 of them. And it's also possible to debug it and kind of get it to do extra stuff. And this, I think this is kind of, it's a really nice example of a company boxing clever and doing something interesting and building a community around its products. They sell the hardware, but they haven't closed down the controls. So it's not the case that you have to use their iPhone app to talk to the device. Anything can talk to the device, and all sorts of interesting stuff happens that way. And there's people using them in research projects and that sort of stuff. In fact, the first time I saw them, it was at a conference where the talk was about using these robots to discover an area, and the guys at that talk had like 20 of them, and they sort of scattered over on the floor and mapped it out using their movement sensors and that sort of stuff. A completely custom app that the company didn't build. So obviously we're going to use Node.js. So I also have to ask the question, who's like just starting out with Node.js? Who's tried it out? So you know, what we'll do is we'll kind of, just for people who are kind of new to it or come to the meetup for the very first time, this is just kind of a quick intro to Node so that you know what we kind of what we're playing with and how we're using it. Node.js.org is obviously the website. It's got a really, really nice controller these days, or a really nice installer these days to get up and running. The installer also includes something called NPM, which is the Node package manager. There's about 70,000 open source modules on NPM. It's one of the best parts of the Node ecosystem. You can almost certainly find a module that does what you need. And that module repository is growing really, really fast. I don't have a graph to show you, but it will surpass pretty much every other major language this year. It's the fastest module repository growth ever in the history of programming languages. So Node itself, if you're not familiar with its internals, the reason why it's nice, the reason why it's fast is because it uses Google's V8 JavaScript engine, which introduced a number of really cool innovations. One is it's just-in-time compiled, so your JavaScript is not an interpreted language, it gets compiled into machine code. That's one of the reasons it's really fast. V8 also introduces proper garbage collection, so all of the learnings that came with Java.NET and JVM and CLR, they now apply to JavaScript, so you don't have issues around garbage collection causing significant performance problems. And the last one is JavaScript is a prototype-based language, which means it doesn't have classes. But there's a whole set of research that goes back 20, 30 years around how to do optimizations on class-based systems, method inlining, all that sort of stuff. The V8 engine is really, really smart. It observes your objects and it creates virtual classes by guessing what the classes should be in your system. And then it applies all of these optimizations. So you also get a speed up that way. And it's really, really cool. The other salient feature of Node, the big one, is that it's a single-threaded system. Which means that instead of running multiple threads to do things concurrently, it only does one thing. And then it waits to get input or output. That's why Node is really, really good at writing network applications and gluing stuff together, and really, really bad at doing CPU-intensive tasks. So case in point, if you are writing a web application, you should be hashing your passwords before you store them in the database. You should be hashing them properly. You should be using an algorithm that takes at least 500 milliseconds to hash the password, using a salt, etc., so they're not crackable. The problem is, if you run that password hashing algorithm in your main web server, you're going to lock it up for 500 milliseconds every time somebody logs in, and nobody else, the web server can't respond to anybody else during that time because you're burning the CPU. That's why, if you are using Node to build systems, you often end up running multiple Node processes. This is an example of something I've spoken about previously, but it's something that you need to get used to in the Node world, and you'll actually see it in this talk. It's not unusual to have multiple Node processes running and to have communication going between the different processes. And that's where streams come in, because streams make it really, really easy to set up efficient communications between different Node processes. So in the password hashing example, you probably want to have a separate Node process that does the hashing. It doesn't, and as a result, it doesn't block your web server requests. Okay, so this is the classic example. And if you go to the Node.js website, you see this, and it's the simple piece of JavaScript that runs a web server. And this is the thing about Node: it doesn't require an app server. You don't install stuff anywhere. You just run a single process using the inbuilt APIs. And just for kind of interest's sake, you can run a performance test against this to see how it performs. So this is using the Apache benchmark tool, and this particular test is going to run 100 concurrent requests 10,000 times. And if I run that on my local machine, it's kind of interesting to see what the results are. So that server 0.js is implementing a very simple web server. All that server does is say, hello world, and if I run the test against it, you can see that I get a rate of about 5,800 requests per second. So that's one of the reasons you use Node. If used in the right way, it's blazingly fast. And the practical consequence of that is that you need fewer machines to do the same work. It's cheaper, especially in cloud-hosted environments, to run Node. It's not unusual in a production Node deployment to see that the Node processes in the front-end web servers typically don't get over 5–10% of CPU. If you've done it right, the CPUs are basically just sitting there in their network pan for the most part. Okay. So this is our basic application architecture. So we have the device. We need to send key commands, turn left, turn right, etc., to the device. The device is going to send us location data saying I've moved 4 centimeters forward, etc. So we're going to have a data stream of information going backwards and forwards between this device over Bluetooth to a Node.js process. We're going to have a second Node.js process that's a web server that's going to expose a little graphical user interface that we can use to control the device. So we open up a web browser, it's going to show us a plot of where the device is gone, and it's going to let us, it's going to capture keystrokes in the browser, for turning left and right, etc., and send them back down to the web server. And then we're going to tie together the controller server written in Node that talks to the Sphero device with the web server over a stream. But we'll build this up in pieces. Also, all of this code is on my GitHub account. You can download and run almost all of it. Obviously, if you don't have a device, you can't talk to the device, but you can run the simulator almost to the endpoint. And a lot of the code, especially if you want to set up communications between multiple node processes, is pretty much cut and paste. And it also covers most common use cases. Okay, so the way to think about Node.js streams is to think of them as Node's version of Unix pipes, and that's kind of what they were inspired by. So they really are, in one sense, incredibly simple. They're just bytes being pushed around from one place to another, and they don't really impose any extra intelligence as such, right? They're dumb pipes, essentially. And Node tries to give you a programming model that's easy to reason about, to use these things. Not necessarily easy to learn, right? It's once you get it into your head, it's pretty straightforward, and it provides you with an awful lot of power. Getting your head into that place takes a little bit of work, and ultimately, it's not something you learn from a talk. It's one of those things that you actually have to write code, and you eventually get it. So let's take a look at a really, really simple use of Node streams. The way that streams work is that you take one stream and you connect it to another stream. So you have data coming out of a stream that you pipe over to another stream. So one of the streams is the source of data, and another is the sink of data. And in this example, what we're going to do is read the contents of a file and pipe it to standard output. So we're just going to print the contents of the file. If you look at the way that's done, it's pretty straightforward. This is the whole idea of the Node Stream API. It's meant to make this stuff easy. So var fs equals require loads in the file system module. I take it most people are familiar with the kind of Node basics in terms of how require works and that sort of thing. I'm going to create an input stream using fs.createReadStream. So that is provided for you by the Node API so that you can have stream-based access to files, because you're meant to access them that way for the most part. And then I'm going to take that input stream and I'm going to pipe it to standard out. And guess what? Standard out is also a stream. So in this case, in-stream is a readable stream because I'm reading stuff from it. And process.standard out is a writable stream because I'm going to write stuff to it. And the .pipe method connects the two together for me. And if I run that, you can see I'm just printing out myself. That's the simplest possible case. This is how you work with streams. You take them and you pipe them together. Okay, so this is where you start using streams to do stuff. What you just saw was an example of taking a readable stream and piping it to a writable stream. But what you can do is transform the data in flight. So in this case, what I'm going to do is I'm going to convert all the text to uppercase. Okay, so this has the same basic structure as the previous example. But you can see that the pipe work is starting to get interesting. So I have an input stream, which is readable, and I'm going to pipe it to an upper stream, which converts the contents to uppercase, and then I'm going to pipe that out to standard out. And this is the heart of the entire application. This basic architecture is what we're going to use to build the entire app. We're just going to create this. That's how you actually mix and match things together. What this is also showing us is how you create your own streams that do custom stuff for you. So the stream module is again a built-in module that Node provides, and it gives you a couple of different types of streams that you can just create. In this case, we're using a transform stream, and we're just creating a new instance of the transform stream. And this is making use of a JavaScript idiom, right? So I'm not creating a subclass of the transform object. I'm creating a new instance of it. And its prototype points at the system. And then I'm overriding the definition of the transform _transform method. So if you go and read the Node Streams API documentation, it'll say, if you want to implement a transform stream, you need to create a new instance of stream.transform, and you need to provide an implementation of the _transform method. And that's how you do it. And in this case, our implementation is really, really simple. Data is the chunks of data that come in, convert them to a string, and I convert them to uppercase, and then I call this.push to send it onwards. And I call done to say I'm done with this particular chunk of data. So implementing streams, especially when they're implementing streams, especially when you use the inbuilt ones, is pretty simple. It's designed to be simple. But this transform stream is nothing but a wrapper around a stream that's both readable and writable. This _transform method is just a convenience function, essentially. And if I run that, you can see I've got uppercase output. So there's 4 built-in streams that you can reuse in the same way. You create new instances of and provide custom implementations for. A readable one, which is what we saw with the file, where you read stuff from some data source. A writable one, where you're sending data somewhere. A duplex stream, which is a stream that's both readable and writable. We'll see how you use that in a minute. And then a transform stream, which changes data. And if you think about it, a transform stream must be a duplex stream, right? Because you write something into it, it changes that data, and then you read the data out again. So let's just think about duplex streams and how they work, because this is one of those get your head around it things. So if you have a duplex stream, because you can read and write to it, it's the way that you implement two-way communication. So when you have 2 node processes talking to each other, you're going to see this particular idiom used. So I take my duplex stream and I pipe it ultimately to itself, and that's how I get the data flow working the way I want. So in this example, which is just going to echo the connection. What I'm going to do is I'm going to start a TCP server. Once it's connected, it's going to give me a connection. And then I'm going to pipe whatever is read from that connection back out again. So essentially what I'm going to do here is replicate that first time in the 1960s where somebody typed something on a telex or something like that and characters were printed through a screen. Magic. Beautiful. Unfortunately, Control-C. Sorry. Okay. All right, so let's try and put together an application now. Let's start actually building stuff. So one of the things that becomes a real pain in the ass after a while when you're using Node is browser-side JavaScript. Because you lose all the cool stuff you get in Node. But it turns out that one of the early people in the Node community, a guy called James Halliday, who's better known by his GitHub handle Substack, wrote this thing called Browserify, which is completely awesome. It's brilliant. It means you can write Node.js code and it runs in the browser. And he provides all sorts of stubs and shims and all that sort of stuff to make sure everything works. Obviously, you know, stuff that's like saving files and stuff like that isn't going to work, but that's not what you want to do in a browser anyway. But the really cool thing from our perspective is we can use the stream APIs in the browser as well. The way Browserify works is you give it a JavaScript file which is written as Node code, and it processes it and generates a version which includes all the shims and all the extra magic that makes it work in the browser. So in this case, what we're going to do is we're going to create a simple web app. And what this app is going to do is the following. It's going to just print the current date once a second. Okay, so that's what this piece of code does. But I'm going to print it by writing to a stream. So you can see up here I'm following Node conventions. This code is going to run in the browser. And I'm grabbing the body tag, normal browser-side JavaScript. But I'm going to create a writable stream this time. When you implement a writable stream, the rule is you have to provide an _write method. And it sends you the data, the encoding of the data, and a function called next that you call when you're done. And all I'm going to do is just append the data to the body. And that's all it's going to do. So if I run that, it'll execute this code in the browser as if it was Node.js code. The other part that I need to make this work, of course, is a web server. So let's write a little web server in Node. We're going to use the Express framework because that makes life easy. Express just lets you serve up static HTML in a really simple way by providing a folder path. And we're creating a web server using Express, and we're just going to listen to port 3000. So if I run 0 over here, and I load it up, it starts printing date once a second. But again, the cool thing is I wrote it as if it was working in a Node environment, so I can use streams, which is really cool because now I have a consistent API that I use across the board for my entire app. Okay. So again, using Browserify is really, really simple. Right? You just point it at the file that you want to convert into browser-based code, and it'll go and suck in all the modules and do all the rest of the work for you. And generally, if you're using it in a production build, you're going to use it with you're going to use grunt or something like that to actually run it. Okay, so we now need to get data from the web server into the web browser, and we need to stream it. So the obvious way to do that is with WebSockets. But we want to keep the streaming metaphor going, the streaming API going. So what we can do is use a couple of Node modules that let us actually do this. There's one called WS, which is really handy for accessing WebSockets in general. And then a guy called Max Ogden, who's another one of these Node characters. He's a guy with a really long red beard. He's written hundreds of modules. He wrote this thing called WebSocket Stream. And you use the two of these together to stream, to make Node streams work over WebSockets. So we're going to take the same app, and instead of generating data on the browser, we're going to generate it in the web server and stream it over. So the browser side of this interaction is pretty much the same as before. The only thing that changes is the fact that we're opening a WebSocket, it's a stream, and we're going to pipe the data to our logger. So you can see how I'm starting to set up a situation where when I'm grabbing location data from the robot, it's going to eventually end up in the browser this way. And the web server side of it is almost the same as before, apart from the fact that we're using these WebSocket modules to send data over WebSocket. This extra code here sets up a WebSocket server for us. And when we get a connection, we get a stream, because streams are what we want. And then we write the value of a counter to that stream once a second. So let's start that. Run. You can see how now it's printing out that value. And this is coming over the WebSocket. But the important thing is, it's all a streams API. Okay, it's going to get hard soon. Okay, so here's the other piece of the puzzle. So we need to capture the key presses. There's a slight complication. When we created a readable stream, we were sucking data off the disk, which is the more common idiom for a readable stream, which is pull data as fast as we can get it. But you can't pull keystrokes. They're pushed by the user. So you need to somehow have a readable stream that you can't suck data out of, but you push data into instead, which you then pipe up, and the other pieces further on down the pipework can read from in the same way, and they don't know how that data is getting there. So what you can do is you can use the internal push method to do this. So if we have a look at here. What we've done is we're going to change the way that the standard in stream works slightly. We're going to set it into raw mode because we just want to get the characters correctly. We don't want any sort of line buffering to happen or any of that sort of stuff. To save us a little bit of work, we're going to use something called event stream. This is a module written by a guy called Dominic Tarr, who I guess is one of the early pioneers in Node streams and came up with a lot of the early idioms. It basically means we don't have to write as much code. You'll see how we use it in a minute. What we want to do is we want to have this key presser stream provide us with keystrokes that we're going to pipe to standard out. So we're going to dump them out in the same way that we dumped out the contents of the file. The problem is we can't provide an implementation of the read method because there's no way to do that. But what we can do is hook up the standard input stream. We can listen for data events on that stream. And whenever that comes in, we can push that data event onto the key presser stream. So this is a way to inject data into readable streams. If you think actually that this could be done more simply by just piping standard input to standard output, yes, you can. That's another easy way to do it, and Node looks after the mechanics for you. But that's not going to be good enough for us because we need to provide additional control if we're going to build our app. So if I run this now, I start pressing keys. We've just re-implemented the exact functionality again. By the way, you can see in this case Control-C doesn't work because I've intercepted it and it can't work in the normal way. So let's start getting a little bit more sophisticated about how we manage the keys. Obviously, we're going to need to know if the key is a cursor key or a normal keyboard key, that sort of stuff. So again, instead of doing the work yourself, there's a Node module called keypress that does that work for us. If you look at the implementation, you can see it's exactly the same code again. However, keypress, instead of sending us raw data, generates little JSON objects that tell you what the key was. In fact, it provides you with the character and then a description of the key. So what we're going to do is, instead of just pushing the data, we're going to push an object that gives us more information. And if you're observant, you'll have noticed that I've changed something about the readable stream. I've changed it into object mode. So this is another useful feature of the Stream API. You can either send raw data or you can send JavaScript objects. And obviously sending JavaScript objects makes creating applications a lot easier. So we're going to turn everything into object mode from now on. You can see how I'm using this event stream module here. So my keypresser is now using the keypress module to create semantic descriptions of the key presses. The problem is they're JavaScript objects, which I can no longer print, because otherwise it would just say object. So I'm using event stream to stringify those objects so I can print them out again. And if I run that, now you can see that I'm getting nice semantic descriptions of the keys that I can now use to implement my application. And Control-C still doesn't work because I haven't bothered to do anything with the keys yet. Okay, so this is where we start building our own application because we aren't interested in every keypress. What we're interested in is converting them into things that make sense for us. So the device can turn left and it can turn right and it can start and it can roll forward. It can do a couple of other things. And also we want to solve that Control-C issue because that's really annoying. So this is an example of using a transform stream to start applying your own logic to the data flow. So again, the implementation is exactly as it was before, apart from the fact that we're now putting a transform stream in. And if I go down to the bottom, you can see the architecture of this app. So when you're building a stream-based app, you see a lot of this type of code where you're setting up this pipework and you're sending data through different sets of streams. I've just gone for broke here and implemented all the commands that I'm going to use on this particular transform. The key press is the data that came in, this character or the key description. And what I'm going to do is I'm going to say, okay, if I don't recognize it, it's just a no-op. If it's Control-C, well, then please kill yourself. Otherwise, if you just press C, I want you to randomly change the color of the LED on the robot. Otherwise, I want you to go left or right, roll forward, stop, etc. Change the speed, all that sort of thing. And again, I'm pushing this piece of data onwards to the next point in the pipe. And then I've implemented another transform stream, just to give you an example of how you can use that event stream module to reduce the amount of code you write. And in this case, all it does is observe the commands coming through, and if one of the commands happens to be a die command, process.exit and we're done. Otherwise, send it onwards. So if I run this, now you can see that the key commands are now starting to make sense. This is what we want. And Control C also filled it. So now you've managed to take the stream-based architecture and you're starting to apply your own logic to it. Okay, so how do you actually build an application? An application is something that has state that you modify and that does stuff. So how do you write a stream that maintains state? How do I know what the current heading of the ball is or how fast it should be going? So that's implemented by a transform stream. And this particular example, I'm not just creating a new instance, I'm actually inheriting from the transform stream. The reason I'm doing that is because I want to have some sort of state. I need a constructor. And in this case, this particular controller records the speed it's supposed to go at, the heading, whether the LED at the back is lit, all that sort of stuff. I'm setting the stream to be in object mode, etc. So it's all going to work. This is following one of the Node object-oriented examples. There's lots of different ways to do object orientation in Node. Inheritance can be done using util.inherits. You also have to say the base class.call this to get it to work. There's many different other ways that you can do inheritance in Node. It's a transform stream, so I need to provide an implementation of the transform method. And in this case, all I'm doing is modifying the internal state. So when I turn left and right, I change the heading. And you can start to see how I'm just injecting that back into my pipe work so that it works. If I run that. Now, when I change left and right, you can see the heading changing. So now I've got to the point where I actually have an application. I have all the control structures and the data structures that I need. So I need to hook it up to a UI and I need to hook it up to the device. So debugging and using physical hardware is pretty tedious because it crashes, and in fact there's some sort of weird error in the Bluetooth driver which actually crashes the physical machine completely. So it becomes pretty tedious trying to debug the actual device. So it's useful to simulate location data as if you were connected to the device. So what we can do is we can use a duplex stream to do this, to stand for the device and generate data from it as if it exists. And we do that using a duplex stream. The reason we do that is because the key commands are going to come into this duplex stream, and we're going to ignore them or we're just going to pass them on. But every second, we're going to generate location data and inject that into the pipework ourselves. And we're using the same model as the transform one before because there's some state here. Because it's a duplex stream, you need to implement the read and the write methods. And in this case, we're using that push idiom because we're generating new data every so often. There's nothing to read from. Write is just passing on any commands it gets in. And again, we're just injecting it into the list. So from this point forward, key presses go into this list. And from this point forward, location data goes into the list, goes into the pipes. If I run that, you can see it starts generating data for me. But my key commands also work, and they get interspersed. Okay, so what we want to do is we want to take this control process, we want to hook it up to a web server, and we want to hook that up to the web browser. So what we're going to do is we're going to use a simple TCP stream to push data backwards and forwards. If we go to the control side, All of the code is the same as before, apart from the fact that we're going to try and connect to a TCP port on 8124. The web server is going to open this port for us. And we have the pipe work exactly the same as before. But we're going to change the way that we architect the flow. We create this output string, and what this does is generates strings that show us what keys we pressed. And we're going to send it into two separate places. So this is splitting a stream, allowing you to control how the data flows. One place we're going to send it is the web server, so we can actually see what's happening. And because we want to debug it, we're also going to send it to standard out, the same as before. The web server is the same web server you saw before with the web sockets. But it's also going to expose port 8124 and wait for connections. When those connections come in, we have a WebSocket stream and we have a control stream, command stream that we want to hook together. So once both of those objects exist, we start at the command stream and we pipe it through to the WebSocket stream. And just so we can debug, we use that event stream utility module to dump out the commands so we can make sure that the data is flowing. So if I start the web server, and I start the control module, just sending location data. So I need to start the browser. You can see that some of the data is already backed up. It's cached it for us. So this data is now being generated by one node process and sent over to the web server node process and then up to the browser. And you can also see it's the web server, spitting it out so you can debug it there as well. So let's shut that down. Okay, so it'd be nice, instead of just getting text, to actually see where the robot is going, which direction it's going. So we can use a library called Fabric.js, which lets you easily draw stuff with canvas. The code to do this with the pipes is exactly the same, except that when we get to the browser, we just take those JSON objects and we turn them into drawing commands. So if I run this, I now have a simulation of the robot moving around. And if I go to the controller and I turn left a bit, you can see that the arrow is now pointing left a little bit because those commands have come through and I'm drawing it. But I'm just generating random location data, so it's all over the place. Okay, so the final piece of the puzzle is we need to actually we need to listen for key presses on the browser and send them back down again. And the key piece of the puzzle there is that we need to make sure that this duplex connection in the web browser lets us pass data not only from the device but also back down again. Because we've set up this duplex connection, the pipes automatically do this for us. But if you look at the web browser side of it, we use a utility module called key to give us the same semantic key presses on the browser side. But we take those key presses and we pipe them into the WebSocket. So now we have key presses going down. And I think there is actually change here. Okay, yes. the command stream is piped up to the WebSocket, but the WebSocket itself generates data and pipes that back down to the command stream. So this is a really good example of using this duplex pattern to get data going in both directions. And again, what I found personally is you don't really grok this until you actually write it yourself. You kind of see it, but it can be hard to kind of simulate in your head until you've actually written the code. And that lets us finally have a situation where we can actually control it from the browser end of things. So now if I turn left, you can see it's turning left, this is capturing the keys on the browser. So the final piece of code is where we actually talk to the hardware. And by the way, if you're ever developing stuff with hardware, this is the right way to do it. Build as much as possible before you can go anywhere near the hardware, because the hardware is going to give you so much trouble. Some people not absolutely. Well, we'll see if there's any scars now. Okay, so we've written all the code that we need. The final piece is we have to grab data from the device. So there's a modified version of that control process. Looks exactly the same as before, except that the random locator has been replaced by the Sphero-derived duplex stream. And that simply makes calls into the Sphero API to change its speed and its direction and all that sort of stuff. So you can see how I'm looking at the command and I'm saying, if I press right, change the heading to be right, all that sort of stuff. And I've written a bunch of more normal code here to connect to the device and print out a nice little help. Tells you how to drive it. So, and finally, I'm setting up the pipes, and I'm not doing any more debugging. So, all I'm doing is looking for key presses that come in, sending them all the way back out to the client, which ultimately ends up in the web browser, and the client is sending me key commands, which I send to the key presser. And the commands that come in here on this line of the key presser go back in at the top here and then are acted on. So, let's start up the web server. Now, this is where the fun starts, because we have to get this device to actually work. Let's see, does it actually play all this time? Look at that. Hey. Okay. So you can also see that the location trail and the directions you're going in, all that sort of stuff works. And you can change the color, all that sort of stuff. I'm just going to make it go slightly faster. Anyway, it's like if you have model airplanes, right? Actually getting to fly is like 1%. Fixing the thing that crashes is the 99%. Yeah, the Bluetooth connection is unstable because the Node module that I'm relying on is one called Serial Port. Doesn't seem to play nice with Mac Bluetooth for some reason. I don't know. But it kind of works sometimes. Okay, thank you very much.
So it's the Node module that's communicating with the Bluetooth hardware that's unstable?
Yeah, it thinks it's talking to a serial port.
Okay. So have you heard of BlueCat? It's like Netcat for Bluetooth.
No.
So I'm wondering if there's a way to... I don't know how the BlueCat software works exactly,
yeah.
but I'm wondering if you could connect Node to the BlueCat.
I suspect it's an unclean shutdown. So when I tested it before I came in here, I think when I Control-C out of the app, I screwed it up basically. But I don't know, and you could spend many days on that.
So, any other real world examples for streams, like where that might be used?
The place where we would use this in production systems is when we're building. A lot of the systems that we build are based on this microservice architecture. So this is where you have lots and lots of different node processes, 20, 30, 40, lots of them. And they need to be able to communicate with each other. They need to be able to communicate with message buses, that sort of stuff. And the stream API is a really useful way for doing that communication. It gives you much more succinct code because you end up going down to the bottom of your code and looking at stuff like this, and you can instantly kind of see how the app fits together. If you need to add extra pieces of functionality, it's just another stream. So it's a really weird way of building an app. And like I said, my initial reaction was, can't really do it that way. How could you just have data flow as your only concept in your application? But it can actually work. I'm guessing it's more relevant in some cases to stuff like games where you have key press data going backwards and forwards. But in the back office architectures where you have different processes in communicating, it works quite well.
If some of the file processing in the middle, for some, you're doing some transformation, and it was actually slowing down the stream, there's some kind of back pressure mechanism.
Yes, yes.
But where does it stop? Does it stop on the producer of the stream, on the initial one, or on the first pipe? The question being, if it starts to get really slow and things start coming, does it start to grow in memory, or does the
memory starts to grow? Yeah, and generally, what I'm doing here is I'm relying on the inbuilt streams to handle what's called back pressure for me. So if there was a bug in my code and I couldn't send data forward for some reason, the volume of data would build up internally, and you'd eventually run out of memory. And that's something, in a production environment you have to be careful about, where you have large volumes of data going through, and if the processing chain blocks, you have to deal with that in some way. But obviously, that's all that error handling code kind of messed up this particular example. Handling back pressure is kind of, I guess you'd call it one of the more advanced levels when you're dealing with streams.
I guess, like, looking at RxJava or Actors, that the pipe is almost like a flat map operation, so maybe that's a bit simplistic. Is there a nice way of handling failures and stuff like that and staying in the stream?
Yeah, failure handling is kind of a tough one. So obviously, if the network goes down, you're kind of in trouble. Generally the architecture we use there is that it's crash first, as in, if the network goes down, the whole process should actually exit and come back up again, so you can actually reconnect. For semantic errors, if users input invalid data or a CSV file row didn't parse properly, when you're constructing your own mini protocol with the JSON objects, it's generally best to have like an error flag or an error property in them, and then you have to handle that yourself. But the underlying transfer mechanism doesn't fail, it's not an error of transfer.
What was the node module that you connected with your Bluetooth?
Serial port.
Is there any browserify way to do that? Is there a way for like the browser to connect with your Bluetooth devices?
I don't believe so.
Okay, so you need to be running the server locally then. Okay.
But one day it will, for sure. HTML6. Yeah. The browser is going to take over everything.
Interesting web framework, and you can remember a socket stream, where you use streams basically for doing basically a piece of web framework. So basically, rather than you actually pass the actual the HTML, but if you pass communication is kind of to a stream, the actual browser are actually using standard data collection.
Yeah, and actually, I mean, something like Meteor is basically the same idea, right? It's just WebSockets completely the whole way. I mean, it has pluses and minuses, right? It's more applicable for apps than the actual content sites.
It's interesting use case.
You have to be careful about building single-page apps. One of our early projects was the Sunday Business Post, which we built a single-page app, and realized 3 months in that a newspaper needs to be properly search engine optimized, and a single-page app is after that. There are workarounds.
Yeah.
Could you combine some kind of node application that wrote a standard out and then use it in Unix with piping into some other non-node application?
Oh yeah, absolutely. Yeah, I mean the Node. So Node supports Unix sockets as well, and it just treats them like any other socket. Okay,